We've spent a good deal of time talking about limits and looking at them both in terms of graphs and tables. And what we're going to do now is we're going to shift for a couple of videos and talk about limits when we're just looking at the function in its basic form. This is going to be the main way that we're actually tested um, on looking at functions. So it's the most important thing, but having that intuition from before to kind of apply to what we're doing now, I think is going to help us out a lot. So let's take a look at actual limits of functions. Now, the first rule that I want to tell you, and this is important enough that I'm going to call it Rule 1. So Rule 1 says, let's say that we're taking the limit as x approaches 3 of 2x plus 1. So what do you think that might be equal to? Well, our notion at this point is to kind of plug in numbers that are near 3. And if I plug in 2.9, then I'm going to get, let's see, 5.8 plus 1, which is 6.8. If I plug in 2.999999, I'm going to get almost the same thing. I'm going to get 5.9999998. Okay, or I'm sorry, 6.9999998, because we need to add 1 to it. So the idea, the same thing is happening when I plug in numbers that are really close to 3, but above it. If I put in 3.000001, what I'm going to get out of this expression is 7.000001. So rule 1 just says that if you've got a limit and just plugging in 3 in for x here gives you an ordinary number and something that you can deal with, then that's going to be your answer. All right, so it's just as easy as saying that 2 times 3 plus 1 is equal to 7. So limits work really well for that. Anytime that you're plugging in numbers and adding, subtracting, multiplying, dividing, raising to powers, as long as you have an answer that makes sense, that's going to be the limit of that expression. All right, now let's start looking at a bunch of cases where our answer doesn't necessarily make sense, and we're going to start making sense out of it. All right, let's take, in the last few videos, we've been talking about the limit as x approaches infinity, and the rest of the videos we're going to talk about are going to be talking about the limits as x approaches infinity, and towards the end we will mix in some x approaching negative infinity. And let's use that same function we did before, 2x plus 1. So just for intuition's sake, let's make a little table here, 2x plus 1. So if I put 10 into this function, I would have 2 times 10, which is 20, plus 1 is 21. If I put in 100, I would get 201. If I put in 1,000, I would get 2,001. If I put in 1,000,000, I would get 2,000,001. All right, so as this sequence is approaching infinity, as my inputs are approaching infinity, what are my outputs approaching? Well, some people that I've been talking to in class have been saying that this approaches to infinity plus 1, and I suppose that's true, but thinking of it in a much simpler way, this is a sequence of numbers that is growing larger and larger, and it's not stopping. Any more than this sequence is not stopping, this one isn't going to stop increasing either. So this limit just approaches infinity. All right, so whenever we've got a function x approaching infinity and we've got something complicated here, but we're just adding, subtracting, multiplying, and or dividing infinity times ordinary numbers, our answer is going to be infinity. All right, and let me give you one other question just to test you a little bit. What if we had x divided by 1,000? All right, so we've got this number approaching infinity, but we're dividing that number by 1,000. Does that change our answer, or is the limit still infinity? Well, once again, we could create a table for this. So 10 divided by 1,000 is 1/100th. 100 divided by 1,000 is 1.1. 1,000 divided by 1,000 is 1. And so these look like they're really small numbers, but notice that they're increasing by a lot. When you get a number like a million dividing it by 1,000, you get 1,000. As this, and once again, as this column gets bigger and bigger and bigger, so is this column. Even though it's getting bigger slowly, it's still not going to stop increasing as these numbers over here are increasing. So once again, this limit is going to be infinity. All right. And so the idea, and I'm going to call this rule 2, is that if we've got a fraction and the numerator is approaching infinity and the denominator is just staying the same, the limit is going to be infinity no matter how big the denominator is. All right. So this gives you two basic ideas about ways that you can evaluate limits without looking at the table. Okay, so I just made the table so we could have something to talk about, but you could figure these things out just using your intuition. So as X goes up from 1,000 to 1,000,000 to 1,000,000,000, you can see that even dividing it by 1,000, this number is going to get bigger and bigger and bigger and bigger. And we express that mathematically by saying that this limit is equal to infinity.